Welcome! Today we'll be going through C2 from the International Maths Olympiad shortlist 2021. Let n greater or equal to 3 be a fixed integer. There are m greater or equal to n plus 1 beads on a circular necklace. You wish to paint the beads using n colours, such that among any n plus 1 consecutive beads, every colour appears at least once. Find the largest value of m for which this task is not possible. Please pause the video here and have a think about the problem on your own before proceeding to the hints and solutions. Hint number 1. Let there be r red beads, where red is the bead colour that occurs the least. In terms of m and n, what is the maximum value of r? Hint number 2. It may be helpful to think of m as m equal to nk plus j, where j is between 0 and n minus 1. Hint number 3. Consider all the strings of n plus 1 consecutive beads. How many are there? Hint number 4. Across all strings of n plus 1 consecutive beads, how many red beads will you count? Note that you can count the same red bead more than once. Hint number 5. For large enough m, can you find a way to always construct a necklace consisting of strings of beads 1, 2, 3 to n, and strings of the beads 1, 1, 2, 3 to n, where each number symbolises one of the n colours. Motivation. In this section, we'll explore a couple of steps which could lead to a solution. For some m, we want there to be a colour, say red, and a string of n plus 1 consecutive beads for which there is no red bead in that string to get a contradiction. Now it makes sense for that colour red to be the least frequent bead colour, so let us make that the case, and let there be r red beads. Then m is greater or equal to r times n, since there are n colours, and r is the number of beads of the least occurring colour. And so, because r is an integer, r is less than or equal to the floor of m divided by n. This may prompt us to write m as nk plus j, where j is between 0 and n minus 1, to get rid of the floor symbol. And so we get that r is less than or equal to k. Now let's consider the number of strings of n plus 1 consecutive beads in the necklace. For m equal to n plus 1, the answer is 1, namely the entire necklace. For m equal to n plus 2, we have n plus 2 strings. There are n plus 2 possibilities for the final bead in the necklace that is not included in the string of n plus 1 consecutive beads. In general, we see that for m greater than n plus 1, there are m strings of n plus 1 consecutive beads, as we can imagine each of the m beads being the start of a unique string and defining a string as a starting bead and a fixed direction, say clockwise. So with nk plus j beads, there are nk plus j strings of n plus 1 consecutive beads. If we expand on the idea of being able to define a string based on the placement of a particular bead, we can see that all nk plus j strings of n plus 1 beads, amongst themselves, will count each bead n plus 1 times, as each bead can be the first, the second, the n plus first bead of a string exactly once. So considering all nk plus j beads, we will count r multiplied by n plus 1 red beads. Now we want there to be a string without a red bead for a contradiction, and so the number of counted red beads r times n plus 1 to be nk plus j minus 1 or less. But we know that r is less than or equal to k, so r times n plus 1 is less than or equal to kn plus k. And so if k is less than or equal to j minus 1, there will be a string of n plus 1 beads without a red bead by pigeonhole principle. So we have that r is less than or equal to k is less than or equal to j minus 1 if we want a string of n plus 1 consecutive beads to be without a red bead. Now, because we are trying to find the maximum n, where our task of finding each colour in each string of n plus 1 beads is not possible, we should maximise r, k and j, and so consider r equals k equals j minus 1 equals n minus 2, since j is less than or equal to n minus 1, as that is how we define j. Then m is equal to nk plus j is equal to n multiplied by n minus 2 plus n minus 1, which is equal to n squared minus n minus 1, and r is equal to n minus 2. Now we suspect that m equal to n squared minus n minus 1 is the largest value for m, which our task is not possible. We should check that this is indeed the case and begin to formulate a solution. Solution. We will argue the largest m for which the task is not possible is m equal to n squared minus n minus 1. We will begin by showing that for m equal to n squared minus n minus 1, the task is not possible. Let there be r red beads of the least occurring colour, say red. Then r times n is less than or equal to n squared minus n minus 1, and because r is an integer, r is less than or equal to the floor of m divided by n, which is equal to the floor of n minus 1 minus 1 over n, which is equal to n minus 2. Now let's consider the number of strings of n plus 1 consecutive beads. Like we discussed in the motivation section, each of the n beads can be thought of as the start of a unique string with a fixed direction, say clockwise. And so there are m equal to n squared minus n minus 1 strings of n plus 1 consecutive beads. Considering all n squared minus n minus 1 strings of n plus 1 consecutive beads, we'll count r multiplied by n plus 1 red beads, since every red bead, or in fact any bead, will be counted exactly n plus 1 times, as it can be the first, the second, the third, the n plus first bead of a sequence exactly once. Now, since r is less than or equal to n minus 2, r times n plus 1 will be less than or equal to n minus 2 times n plus 1, which is equal to n squared minus n minus 2. So among n squared minus n minus 1 strings of n plus 1 consecutive beads, we'll count at most n squared minus n minus 2 beads, and so by pigeonhole principle, there must be a string of n plus 1 consecutive beads consisting of no red beads, as required. Now to show that for m greater or equal to n squared minus n, a task is in fact possible. Let us express m as nk plus j, where j is between 0 and n minus 1. Then k is greater or equal to n minus 1, which is greater or equal to j. And so we can construct a necklace consisting of k minus j strings of the beads 1, 2, 3 to n, and j strings of the beads 1, 1, 2, 3, n, where each number symbolises one of the n colours. We can indeed check that this will give us n beads, since we have n multiplied by k minus j plus n plus 1 multiplied by j, which is equal to nk plus j. Hence, we have shown that n squared minus n minus 1 is the largest value for which our task is not possible. Thank you for watching this video. I hope you enjoyed it. Feel free to drop a comment in the comments down below. and see you next time.